Hi, sorry. Hi, for this video lecture, I'm going to talk about memory management. So, the operating system manages the memory systems to ensure efficient execution of processes while protecting them from each other and to optimize the use of the memory resources. Processes are moved back and forth between main memory and disk during execution. The OS keeps track of each and every memory location, regardless of either it is allocated to a process or if it is free. It checks how much memory is to be allocated to processes. It decides which process will get memory at what time. It tracks whether some memory gets freed or unallocated, and correspondingly it updates the status. So this is the memory hierarchy. The figure at the right shows the memory hierarchy for different storage devices and memory systems. It compares the response time or speed, storage size or capacity, cost, and the distance from the CPU. So here you can see in the pyramid, the highest memory system is your registers, because registers are the memory location within the CPU. So if you're going to look at here, as you go up, your memory location or your memory system, as you go up, it also go fast. So speeds goes up, cost also goes up. So the higher you are in the memory hierarchy, the faster you are, but the more expensive you are. At the same time, you are also the smallest in terms of size. So the lower you go, the bigger you are in size, the slower you are in speed, and the more or the less expensive you are in terms of kilobytes or gigabytes per peso or per dollar. So this is your memory hierarchy. Another thing to consider or to remember is that all of these are called memory systems or storage devices. So, but when you talk about memory, not all of them can be considered memory architecturally. Logically, all of them are memory because they can store data, but some of them cannot be considered as memory in terms of architectural. When you consider architectural, how they are connected to your CPU. So hard disks are logically considered as memory because it can store data, but architecturally, since it will be connected to your system, to your computer system through an I/O port or I/O bus, so it's considered to be an I/O. So that's just a trivia. Okay, for a context, if you're going to put these things into a context, so in a computer system, the original location of a program is the secondary memory. So normally that's where you save your program that you wanted to be run. So you put it in the hard disk, or probably you put it in a USB, or probably you put it somewhere in the cloud and then you save it in the hard disk before you can run it. So it's basically in the secondary memory. Or if it's in the cloud, it's still somewhere there in the secondary memory of some hard disk where it's saved. A program is broken down into processes and threads when executed. The processes are loaded into the RAM. So from your secondary memory, then it will be broken down into processes and threads, and then it will be loaded into RAM, ready to be executed. But the execution does not really happen inside the RAM. You have to remember that. The execution happens, of course, in the CPU. And all this data have to be placed in your registers. Okay, the CPU only directly access the registers, cache, and RAM. And then the registers are the fastest, as 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 fast as the CPU, so they're the fastest memory location. Cache and RAMs are slower. Secondary memory is by far the slowest. Processes and data transfer to and from the memory systems and CPU. Okay, memory management techniques. The following are the three key management techniques used by the OS. First is segmentation. Second is paging. Third is swapping. Segmentation refers to the technique of dividing the physical space into multiple blocks. Each block has specific length and is known as a segment. So paging is a technique in which the main memory of computer system is organized in the form of equal sized blocks called pages. And swapping is the technique used by operating system for efficient management of memory space of a computer system. Swapping involves performing two tasks called swapping in and swapping out. Okay, so let's look at the segmentation. So here you have a sample of how your memory will look like. So you have three segments there, and then you have the base address, equivalent base address for each segment, and then you have the limit. So this is a graphical representation of how your data will look like. So of course the segment 1 having the limit of 600 will be the biggest segment, and then segment 3 having a limit size of 500 will have a second in size, bigger in size. And then the smallest is the segment 2, which is only a limit of 200. So if you're going to look at them in the memory location, so here you have, this one is your first segment. You cannot really see the color. It's supposed to be light blue. So it starts with 400 since your base address is 400. So this is one segment. So each of this one is page. So each page here, so 400 is one page, 500 is one page. So you have the limit is 600. So they have 1, 2, 3, 4, 5, 6. So from 400, since your base address is the start of your base is 400, it will end to 900. This is one segment. This is segment 1. Your segment 2 starts at 1300 or 1300. So this one 1300s, and there are only 200. So each segment is 100. So here you have only 1300 to 1400. This is for your segment 2. And for your segment 3, starts at 1800s. So 1800. So you have 500 as your limit. So 1, 2, 3, 4, kulang 5. So it should be from 1800 to 2200. So you have 3 segments, different sizes, and as you can see that there are some pages here, some are not used, or some location, some segments are not used, not pages, some segments. Okay, now let's look at paging. So here an example is your process 1 is smaller in size. Process 2 is a bit bigger than process 1, and process 3 is the biggest so far. So in paging, you will not see the table, but instead you will just have to imagine that you will have this different data sizes that have to be placed in your memory using paging. So this is how it will look like. So process 1 will be placed here in the 500, or it could be placed in the 400, and then each this one is called one page each. So process 1, we assume that it needs to occupy 3 pages. So this one to 500 to 700. Process 2, we just assume that it needs to occupy 1, 2, 3, 4, 5 pages. So it's from 800 to 1200. And page 3 needs to occupy 1, 2, 3, 4, 5, 6, 7, 8 and a certain part. of a page. So here, started with 1300 going down. So the difference between the first one and the second one, as you can see, that there is no blank memory location in between the different processes. So they are fitted right right after each other. So segment 1 complete here, segment 2 here. So it could be the segment 1 starts at 100, then ends at 300, then segment 2 starts at 400, and then ends in etc. So that's how paging works. Okay, so swapping. Swapping involves secondary memory. Actually, in paging, and the other one is segmentation. Paging and segmentation, of course, it involves secondary memory, but only at the beginning. But in swapping, all throughout the processing of your program, there is a movement of data from secondary memory to primary memory. So normally you need swapping if your program is relatively huge. So it cannot be fitted, or there is not enough second primary memory for it to be placed there, or probably your primary memory is already loaded with other programs. So you will need swapping. So here, this is our main memory. So you have to understand that I just enlarged the main memory, but in reality, your secondary memory is usually much bigger in size compared to main memory. But anyway, so in your main memory, a certain portion there is allocated for your OS. So it cannot be used. It's only for OS. And then the rest can be used by the user or by the programs that you execute. So here, basically what happens is just swapping from one memory location or from one memory system to the other. So but that's how it works. Okay, so for more reading and viewing, these are the recommended sites. You can visit them, and you'll have much better understanding of what memory management is. Okay, so I thank you for watching this video.